Recently, I was exploring different types of fertilizers used in agriculture. You know, Laura, I didn't realize how essential ammonia is in producing fertilizers like urea.
Yes. Ammonia is the key. Without it, we wouldn't have the nitrogen-based fertilizers that help feed a huge part of the world. It's literally the backbone of modern agriculture.
Exactly. But the crazy part is how energy-intensive it is to produce. Almost all the ammonia we make comes from the Haber-Bosch process, and it uses massive amounts of energy, high temperatures and pressures.
I know. The Haber-Bosch process was revolutionary when it came out in the early 1900s. Before that, people were using things like bird guano to get nitrogen. But this process made synthetic fertilizers possible and changed agriculture forever. Still, if we could lower the energy use, that would be a real breakthrough.
That's where this new tech comes in. Researchers at RMIT University in Australia and their partners are working on a process that can produce ammonia with a fraction of the energy. They're using liquid metal catalysts like copper and gallium, which drastically reduce the amount of heat and pressure needed. It cuts the heat by 20% and pressure by 98%, and it still gets the job done just as efficiently.
No way. Liam, that is a massive improvement. And cheaper too.
Yeah, much cheaper. Liquid metals are more efficient at speeding up the reaction, and because they lower the need for extreme conditions, the cost of energy drops dramatically.
How does the liquid metals make the process better?
It's all about how liquid metals work at the atomic level. The cool part is that the metal atoms in liquid form are mobile, and this movement helps modulate their electronic and geometric structures. It's like the metals become more dynamic and adaptable, which boosts the overall reaction efficiency for producing ammonia from nitrogen and hydrogen.
So, it's like they're using the natural properties of these metals to make the whole process smoother.
Exactly. And by purposely designing disordered metal catalysts, the researchers can fine-tune how these reactions happen. They're basically creating a dynamic metal complex that works better than the old ruthenium-based catalysts. The molten copper-gallium combo they're experimenting with has this synergy between its components that makes it more active than ruthenium.
That is really incredible.
Plus, think about the environmental impact. Traditional ammonia production is responsible for about 2% of global carbon emissions. If we can start making ammonia with less energy, agriculture could cut down its carbon footprint in a big way.
And that is huge, when you think about how much of the world depends on synthetic fertilizers. If we can reduce the emissions from production, it would make farming a lot more sustainable.
Exactly. Reducing the energy used in ammonia production means less reliance on fossil fuels, which is a big win for the environment. Less energy, lower emissions, and more sustainable farming practices. We're looking at the future of agriculture here. A whole new era. Greener, more efficient, and more sustainable.